All right, everyone. We're going to spend this hour on lead-acid aircraft battery airworthiness. If you don't know who I am by now, I'm Chris Holder with Concorde Battery. I manage most of the eastern United States for Concorde. And so let's just go ahead and get right in it. Get my screen to move. There we go. All right, so the agenda today, we're going to do a quick introduction in the history of Concorde Battery. We'll get into the different technologies. We're going to talk some safety with batteries, servicing and charging, how you clean one, installation eligibility, how to optimize that battery to make its life as long as you can. We're also going to be discussing the airworthiness issue and what that means with batteries. You know, in a lot of other segments, airworthiness is a very black and white issue, but it seems to be when it comes to batteries that there's some gray area. So we will try to clean that up. So Concorde is a family-owned company, started in the late 70s by the Godber family. We are in our 44th, getting ready to be our 45th year, if my math is correct. We brought the sealed recombinant gas battery to the aviation industry in the late 70s, early 80s. The King Air was our first application on the civilian side. The F-18 was our first application on the military side. But what probably put us on the map was the F-117 application in 1986. When that picture was published, we found out that we were the sole source battery for that aircraft from beginning to end, and it was parked back in 2009 in the boneyard. And so that really put Concorde on the map. Today we have applications for a little over 70% of the U.S. military's inventory. So, and then on the GA side, of course, most piston application, many corporate aircraft applications, and we do have heavy iron applications as well, mostly in the Boeing series. So you're going to see this a lot throughout the presentation. This is the component maintenance manual. We refer to this as the Bible. Everything that you need in terms of knowledge, how to perform a specific task, is all in that manual. So please refer to that manual. One of those comes in every container that is shipped with a battery. You can also go to our website, concordebattery.com, which is a brand new website, very clean, very well put together. You can find our component maintenance manual there as well. So the current technologies that are out there right now, obviously lead acid batteries, NiCad batteries, which very popularized in the 60s, and then lithium ion has made an entrance over the last 5 or 6 years. And I want to focus on that just for a minute. Now, Concorde is definitely not ignorant of lithium ion battery technology. We have been building test articles for the F-18 for the Navy for over a decade now. So we're very familiar with the technology. It has some very recognizable advantages, and then there are obviously some concerns. Now, fundamentally, it's half the weight and roughly a third more power. And so, you know, in the aviation business, weight is the holy grail. You know, if you go to an aircraft manufacturer and tell them you've saved 2 pounds on a particular widget and you haven't changed the profile, you get to play golf for free all summer long. If you shave half the weight off of something, they name children after you. I mean, weight really is that important in the aircraft manufacturing business. But there are some concerns. Back in 2011 was really the first instance of it. There was a Dreamliner parked at the gate. Was not hooked up to ground power. The batteries lit up. The fire department was there in about 120 seconds to put the fire out. It took them over 2 hours to extinguish that fire. It burns very similar to magnesium. If any of you have seen a magnesium wheel go up, typically some of those military aviation videos, you really can't put that out until you take the oxygen out of the environment. And so it is a very difficult fire to extinguish. Now, there are protection and monitoring systems in lithium ion batteries in the headspace now to shut them down if there is a thermal runaway. Cost is also a serious concern. It's very difficult to ship lithium-ion batteries. Disposal, yes, they are recyclable, but is extraordinarily expensive to do that right now. And is the industry ready? There are some applications out there, but it really remains to be seen how the industry is going to receive that as a whole. So let's talk about some battery basics. The old flooded style battery consumed water through electrolysis. The water had to be replenished at fixed intervals or when it was necessary. It was always something to chase, and it fundamentally leads to shortening the life of a battery if you don't do it properly. Gel batteries, gel was really the first non-spillable carrier for acid. But what we discovered is very, very quickly, in fact, that when you have an energy transfer, oftentimes voids would develop in the gel. Think of a slice of Swiss cheese. And any part of the plate where a void was represented would not charge that portion of the plate. And you really only need your battery for a couple things. One is to start your aircraft. The other is to provide you with essential power if you lose your alternator or your generating system. So gel came and went very quickly because simply you couldn't meet minimum capacity when you were charging a battery and you had those voids. So the sealed technology really is it right now. Recombinant gas, it's known by a lot of different things. RG, you'll find that at the beginning of all of our part numbers. And that stands really for how the battery operates. Sealed batteries have eliminated 1/2 of what it takes to keep a battery moving efficiently throughout its life, and that is fluid replenishment. So recombinant gas simply refers to how the vent valves work. They're specifically designed to recombine the gas back into the mats, into the AGM mats. So you never have to service the battery, nor really can you, from a fluid aspect. And then they're also known as AGMs. This is a very common nomenclature, absorptive glass mat, and then valve regulated sealed lead acid, VR SLAs. Slabs is another one, sealed lead acid batteries. But let's take a look at these photographs. The picture on the left has 2 cells in it. The cell on the left is a sealed cell. The cell on the right is a flooded cell. Let's deal with that one first. You see the brown line there in the photo that represents the plate. And you notice that plate doesn't come all the way to the bottom of the box. And additionally, there needs to be space around plates in a flooded battery to allow that electrolyte to move around. But as that happens, that process actually washes lead oxide, the active material, off of the plate, and it settles down at the bottom of the box. It's mud. And so what those cells have to sit on, what those plates have to sit on, is a mud rest, because if that mud were to build up too high and touch the bottom of the plate pack, it would short that plate pack out. So not too many, not as many plates, not as big in the flooded cell. The cell on the left, that's a sealed cell. You can see the plates, the brown line, it runs all the way to the bottom of the box. And there's a reason for that. The acid resides in that absorptive glass mat. It's kind of a foamy square. We soak that to a little over 90% capacity, and then we can sandwich that in between the plates. So we don't have to have that space, so we can get more plates in there as a result. We also don't have to worry about the mud issue, and so we can run the plates all the way to the bottom of the box. So you've got more plates, larger plates in a sealed battery. That represents about a 20% increase in power over a stock flooded battery. Now, we have what we call platinum series batteries, and you'll see that on all of our 24-volt batteries. On the 12-volt side, you have the option of selecting standard sealed batteries or the platinum series. The platinum series simply means that there are a few more plates per cell, and it's roughly an 18% addition in increase in power. So we're talking 38% more power over the old flooded style batteries. So it is a tremendous difference in power. Now, this is a cutaway of probably undoubtedly our most popular turbine battery, the RG380E44. And you can see the cell packs there. You see the tall gray wall, that's the cell divider. Start with the terminals, the Elcon connectors. It's copper. It's an improvement in high rate discharge. It's also more efficient with engine starting. And then you have your intercell connections. And fundamentally, this is a really big part of what separates our batteries from everyone else's. We are one of the last battery manufacturers on the planet that still builds aircraft batteries by hand. And when you do it in an automated process, you spot weld those cells together down below where you see the cell wall there. And that spot weld is about the size of a pencil eraser. And because batteries live in a vibratory environment, sometimes those spot welds crack, but more often what happens is the vibration warbles out the hole in that cell wall. And even in a sealed battery, it allows those gases to walk back and forth between those cells, and it will neuter those two cells. So what you're looking at here is what we call an over-the-partition connection. And if you put your thumbs together, that's about how much lead is there for that one intercell connection. It affects discharge and charge efficiency. It makes it much more efficient on both sides. And then you have your electrodes, quantity, surface area, determine battery capacity, as we spoke about. Thickness affects the high rate discharge. So those are some of the differences between our batteries and everyone else's. Now let's talk about temperature versus power. You know, in the automotive industry, there's a marketing term that everybody's familiar with called cold cranking amps. Well, on the aviation side, we refer to that as IPP and IPR ratings, initial peak power, initial power rating. IPP is measured at roughly 0.3 of a second when you hit the switch, and then IPR is measured 15 seconds down the line. So if you take a look at this first column, and what we're using here as a reference is the 44. So at IPP, it's kicking out 1,350 amps. At IPR, 15 seconds down the line, it's pushing out 1,000 amps. And that's at roughly room temperature, and that is the peak operating temperature for lead acid batteries. So if you move to the second column and you look at 0 degrees Fahrenheit, you can see how the power has dropped off dramatically. And at minus 22, the drop off continues, but it's not quite as different. And the point of this slide is to help you understand that temperature affects battery performance. If you're going to be operating in cold climates, you know, it's best to use heater blankets or actually remove that battery, get it into the FBO office, get it into your hotel room, anything that will maintain that battery in a reasonably warm climate. Now, we have spent a tremendous amount of time and man hours and money over the years developing our batteries to the point where they actually work better than NiCads at minus 22 and below. But the point here is to understand that temperature means everything when it comes to battery performance. Now, some years ago, I think it's been 5 or 6 years at this point, there were some doctors down at the South Pole who were very ill, and there had to be a mission to go down there and get them. And Ken Borak sent this Twin Otter down to get them. That battery was soaked at minus 60 overnight. And of course, they were able to get that aircraft started, no problems at all, and get those doctors back to get them the medical attention that they needed. So the point here, obviously, is that Concorde really is the preeminent cold weather operations battery, period, end of sentence. Now, when we talk about battery safety, there's not a lot to talk about, but one of the main concerns is that these batteries are heavy. The turbine batteries anywhere from 60 pounds to nearly 100 pounds. Now, several years ago, we added straps to the top of our turbine batteries. And those straps can hold up to 8 times that battery's weight. So they are very durable, but it makes it much easier to move batteries around. Y'all work in hangars where typically you have a nice sheen of sweat on your hands. So if you're not going to use those straps, the containers can be very slippery. So maybe a pair of engine gloves, anything to give you a good hold on that battery as you're moving it around. Carts, obviously, in the hangar. Use carts, put the batteries on the cart, move them around when you've got great distances to go. Shock hazards are also a very real issue when it comes to batteries. Now, these Elcon style connected turbine batteries, you simply, if you're carrying them, moving them around, make sure that you've got a dust cover on that Elcon connector, or at the very least, make sure the Elcon connector is facing outboard when you're carrying it around. You know, the stories are true. A long time ago, some fella in Texas welded a belt buckle to his belly. So he's got a nice picture of it there on his belly. So you got to be very careful with that. Again, refer to the component maintenance manual. You can find that on our website. You've probably got them around the shop using Concorde batteries because, again, one comes in every box. So true or false? Should you or should you not store charged batteries on the ground or on a concrete floor? Well, this came from kind of an old myth. If you guys out there have been doing this for a while, you remember rebat batteries. They had a rubberized porous container, and sometimes those containers would leach. And the idea just kind of started swimming around that the concrete was sucking the energy out of the batteries. You know, my grandfather was a fighter pilot in World War II. He taught my dad taught me, always put that battery on a 2x4 when you're setting it in the garage. And that's not really the case. The issue when it comes to storage for batteries is all about temperature. The cooler environment that you can store a battery in, obviously without freezing it, the less opportunity or the less quickly self-discharge will occur, because all batteries do self-discharge with no load on them. So, you know, as an example, you could take one of these batteries fully charged, stick it in a fridge, come back a year later, a couple of tenths of volt would come out of that battery. If you sit it out on the ramp in July, you can bleed a quarter of the energy out in a month if it's hot enough. So temperature really does affect. You want to typically store these batteries in an environment really no warmer than 68 degrees. That slows down the discharge curve. And then just as an aside, you never want to put a shorting spring on a main connector for a lead acid battery. This is obviously someone, and we received this a few years ago in our lab for some testing. This is obviously an individual that spent a lot of time working on NiCad batteries, because you do need to do that with a NiCad before you ship it out. But if you do that to one of our batteries, you've basically turned it into a boat anchor. So please do not short spring these connectors. Now, Concorde batteries may be serviced in any battery facility, including NiCad service facilities. They're sealed now, so there is no cross-contamination. This came from the 60s, particularly in the military, where lead acid batteries are pink to differentiate them from NiCad batteries, and they had to be serviced in separate rooms because they would have cross-contamination of the electrolyte, and it would essentially neuter those batteries. And now with batteries being sealed, that issue does not exist. There's still a lot of concern out there, and folks sometimes still do service these in different rooms. And if you do that, that's okay. Just know that you don't have to do that anymore. So commissioning a battery. Commissioning is putting a battery into service. What's the difference between putting a flooded battery into service and a sealed battery into service? Well, Concorde stopped making flooded batteries roughly about 6 years ago, because there's really no upside to putting a flooded battery in an aircraft as it compares to a sealed battery. But let's talk about commissioning a flooded battery. Well, first of all, you got to take it off the shelf, take it out of the box, fill it full of electrolyte, slosh it around a little bit, let it settle, put some more in there. And then typically what happens is the technician will put a 3 or 4 hour charge on the battery, put it in the aircraft, and send him on his way. And that is enough of a charge to get an aircraft started. But if you do that with what's called the forming charge, the first charge on a flooded battery, you've cut that battery's life by approximately half. That forming charge is a 14 to 16 hour process. And it has to be done that way. And then you have to capacity test the battery, because no flooded battery, not the ones we used to make, not the ones that my friends at Gill still make, are airworthy out of the box. So they must be capacity tested to assure airworthiness. Then you got to charge them back up. That's a 1.5 day process, if you think about it. And in the culture we live in, that's really just not acceptable. To commission a sealed battery, you simply take it out of the box, check the open circuit voltage, put it in the airplane, because they are high rate tested individually at our factory, not once, but twice. It's not a lot test. Okay, we don't pull a battery off of a pallet. We test every one of them twice. They're ready to go out of the box. But it is very important to check that open circuit voltage when you get a battery out of the box, because not all distributors do as good a job as others rotating their stock. So please check that open circuit voltage and make sure that battery has 25.8 is a fully charged 24 volt battery, 1291 for a 12 volt battery, but you want to see those kind of numbers. Anything less than that, down to about 25.25, it needs a boost charge. If it's below 25.25, I'd like you to give me a call, get me involved. We'll get with the distributor and get you a fresh battery, because a battery that's been sitting, has sulfated, it's lost energy, it's going to fail early, and we don't want that to happen. So always refer to the instructions for continued airworthiness, the component maintenance manual, the operator's manual. You'll see in those manuals that activities consist of checking the open circuit voltage, how to charge the batteries, and different charging methods based on what you're trying to do. Obviously, capacity checking, determine airworthiness, and then conditioning charges, physical inspections of the terminals and connectors, and we'll go over some of that in just a few minutes. So the open circuit voltage of a fully charged 24-volt battery is 2582, 2583, right in there. It indicates the state of charge of the battery. OCV does not indicate state of health, okay? They are two totally different things. The battery in this picture shows that it's fully charged, but in point of fact, that battery nowhere near meets minimum capacity for airworthiness. But the healthy part of the plates took the charge. So don't let the voltmeter, and this is one of the most important points today, don't let the voltmeter tell you what state of health is, because it can't. So don't assume that's what it is. Only a capacity check can determine that. And just as a point of reference, you can see all the way down at the bottom, if a 12 or a 24-volt battery has that amount of voltage in it, they are in a 25% state of charge. So it's really important, if you don't hear a lot today, keep batteries fully charged when they're not in use. Now, there are several different charging methods. Constant potential is the type of charging that we do all throughout our lives, every single day, whether we're charging our phones or charging any other type of battery. Constant current is a method used to condition charge aircraft batteries, which we're going to talk about in a moment, but it's not a method that you would typically use anytime other than that. And then maintenance chargers, the black box up there, that is a battery minder made by VDC Electronics in Huntington, New York. They allowed us to work with them about 11 or 12 years ago to develop a maintainer with the right float voltages. The set points were all what we needed them to be to perfectly marry to an aircraft battery, and it allows you to leave a battery minder on for extended periods of time. People ask me all the time, can I just use my maintenance charger that I bought at AutoZone? And the answer is practically yes, you can, but you don't want to leave that on there for more than a few hours, because typically those voltages set points are a little too high. You leave it on there too long, you can dry out the AGM mats, and then you've simply ruined your battery. Now, the equipment that you see there, the red equipment, that's our sister company, Advanced Power Products. They make a wonderful line of charging equipment that you can either get on their website, contact me, and we'll get you some information on that. So at what time should an inactive lead acid battery be boost charged to prevent it from sulfating? Well, it's not really an issue of time, although 3 months can be in the window depending on temperature. But it's any time those voltages fall. 25.5, you want to boost charge a battery. 1275, you want to boost charge a 12-volt battery. You get down to those numbers, it's important to get that energy back in those batteries to prevent them from sulfating, because sulfating is what leads to the end of a battery's life, because it just simply won't accept a charge. And then this is an interesting graph that gives you a display of, depending on temperature, what are the typical boost charge increments. And you can see when a battery is cold, it holds its energy, but as that temperature increases, the need to boost charge that battery from a time standpoint increases as well. Discharge rates, flooded batteries lose 25% of their energy every 30 days at roughly room temperature, but look what happens when that temperature goes up. It doesn't take long for a battery to self-discharge. And any part of the plate that is negative a charge is going to immediately begin to sulfate. Obviously, it's soft in the beginning, but the longer you let it persist, the harder it's going to get. Sealed recombinant gas batteries lose their energy. They self-discharge 3 times slower than a flooded battery. So it's a very important point here. If you don't get to fly that much, or aircraft don't move that much that are in your world, they stand a much better chance of getting those aircraft started because they just don't self-discharge that quickly. Is it okay to fast charge a lead acid battery? We feel that it absolutely is. In fact, our batteries can take up to 8 times the C1 rate, which is on the front sticker of every battery of ours that you use. Now, most chargers will only give you a max of about 25 amps, or sometimes, some cases, I've seen them where they're 50 amps, but we're talking, in the case of an RG380-44, it could accept up to roughly 320 amps. So you're never going to pump that much current into these batteries, but you can. Fast charging is the best way to prevent batteries from having the opportunity to sulfate. The important point here is that you must control the voltage. Automotive batteries have very thick plates in them, and they are designed for abuse, thousands and thousands of starts. Aircraft manufacturers want the smallest footprint that I can give them and the most power out of that footprint that I can give them. And typically the way that we do that is the plates are much thinner, okay? So we can get more plates into each battery to make them more powerful. The downside to that is there's some fragility there. So you've got to be very careful with the voltage, because you can actually warp these plates or in even some cases melt them. So control the voltage when you're charging these batteries. Cap test minimums. Minimum capacity for airworthiness according to the FAA is 80%. Now in 4313-2B, they do talk about 85%. Concorde's minimum battery capacity requirement for return to service is 85%. And I get questions fairly frequently, why is it different? It's no more complicated than an added margin of safety. It's that simple. So cap testing is the only way to determine airworthiness, as I mentioned earlier. It's a fairly simple process to do, but you do need the right bench equipment to accomplish it. You're simply going to discharge the battery at its C1 rate. And I'll again use the 380E44. That's a 42 amp hour battery. So we're going to discharge that, obviously assuming the battery's fully charged first, at that rate. And then if you make it to 51 minutes before you get to the endpoint voltage of 20 volts for a 24 volt battery, you're at 85% capacity. If it goes 54 minutes, it's 90% capacity. Obviously, if it makes it to an hour, it's 100% capacity. And you will occasionally have batteries that go 102, 103, 104% capacity. This determines the intervals for the next capacity check, which brings me to an important point I want to take a moment to discuss. In our CMM, it says the cap check intervals specified are general recommendations. The intervals may be adjusted for a specific aircraft or fleet once the battery life is established. That refers to Technical Bulletin 14, which you can find on our website. And it basically, in a Cliff Note version, says this: when you have installed the first 2 batteries or 2 sets of batteries in an aircraft, and you're getting ready to install the 3rd battery or 3rd set of batteries, you can take the average lifespan of those first 2 batteries or 2 sets and apply that to the 3rd set. So for easy math, the first battery cap test passes at 3 years, fails at 3 years and 6 months. The next one does exactly the same thing. So the average lifespan is obviously 3 years. So for that 3rd battery, when it goes in the aircraft, its first capacity test is at 3 years. Now, if any of you are Learjet technicians out there, you know that's a godsend, because installing and removing batteries in a Learjet is extraordinarily difficult. So this allows you to expand it out. Now, I will say this: if the flight profiles change dramatically, the way the aircraft is operated changes dramatically, you need to go back to the original guidance in the CMM. But this allows you, long-term Concorde operators, to establish a little bit longer interval for your cap checks. And of course, you can find that at concordebattery.com. So how often do you perform these inspections? Well, with turbine batteries, your first check is going to be at 12 months. If it capacity tests above 90%, your next check is at 6 months. If it caps between 85 and 90%, your next check is at 3 months. Now, if the aircraft manufacturer determines that they want you to do this with a different level of frequency, or more often, I should say, then you accede to the wishes of the aircraft manufacturer. So make sure you check with your aircraft manufacturers to see if they are referring you to us or if they have their own designs on their on the technique. So what is sulfation? Well, these are 2 pictures. The picture on the left is a new, healthy, spongy plate The picture on the right is the hardened lead sulfate crystals. Basically, lead sulfate is the lead oxide, negative of charge, turns into lead sulfate crystals and creates a barrier which does not allow the charge to get to the healthy part of the plate. You know, one of the examples that I like to use is a slice of bread that's really moldy on the outside on both sides. And if you pull that mold away, there's some healthy bread on the inside of that slice. But you can't get the charge through those lead sulfate crystals. So you've got to figure out how to get rid of it. These are all the things that it's caused by: leaving batteries discharged for long periods of time before you recharge, repetitive undercharging, going out and flying for 20 or 30 minutes and coming right back and shutting down and not recharging, updating avionics cards up in the cockpit for 30, 40, 50 minutes and not recharging the battery, extended dormant periods, as we mentioned earlier. The longer you let these conditions persist, the harder that sulfation gets, to the point where it is hard and it is unreversible, and basically you've got a battery that's not recoverable and it has to be scrapped. So what can be done to correct it? Well, it's called a conditioning charge using that constant current method that we mentioned earlier. What are the parameters? How do you do one? Again, always refer to the component maintenance manual. So it is a very simple process. The only time you're going to do a conditioning charge is because a battery has failed capacity test. So if you look in the manual, it tells you to discharge the battery to the endpoint voltage, which in the case of a 24-volt battery is 20 volts, 10 volts for a 12-volt battery. But you're already there because the capacity test takes you down to the EPV. So at this point, you're going to take a look at the front of your battery. The 44 is a 42 amp hour battery. You're going to divide that by 10. 1/10 the C1 rate, 4.2 amps. That's going to be your amp rate. You're going to turn the volume up as high as it'll go on your charger for the voltage, which is typically 36 volts. This opens up the path to allow the voltage to slowly climb, and in combination with the current, to turn that lead sulfate back into lead oxide. Now, this is a 16-hour procedure. We can, if you look in the book, you can cut it up into 2 8-hour processes if you don't want this happening overnight in your hangar. But during that 18-hour process, it will clean it up. You need to go over and check that battery every 4 hours. Touch the sides of the battery. Now, toward the end of the process, the battery is going to get warmer because you're going to see voltages in the 32, 33, and even 34 volt range over the end of this test. What you're looking for are hot spots. You know, if you feel a hot spot anywhere on that battery during the process, immediately shut that process down, allow that battery to cool. Chances are you've got a bad cell if you feel a hot spot, but you're just looking for that during the process. And then you're going to recapacity test the battery. And you would be amazed at how effective a conditioning charge is to bring a battery back to an airworthy status. Remedies to prevent it. It's the fundamental message of today. Keep batteries charged when they're not in use. Eliminate parasitic loads. Use a battery minder if you're going to have long downtimes for the aircraft. Battery minders have a desulfation mode. And I will say one thing, because there's not confusion, but I get a lot of questions about the battery minder. The newer minders, the sulfate light is blue, and it blinks all the time. Okay, and it makes you think sometimes that battery is being desulfated. Why is it always being desulfated? What's wrong with that battery? Nothing's wrong with the battery. The battery minders, the blue sulfation light blinks all of the time. It's simply looking for sulfation. So don't let that alarm you. If you forget what I just told you, give me a call and I'll remind you of that. When should you check the aircraft charging voltage? Annually, in the summer, in the winter? Well, the answer is annually. And here is the ranges: 13.8 to 14.2, 27.6 to 28.4 is the range for your 24-volt batteries. If you're willing to adjust this a couple times a year, the aircraft charging voltage, if you'll set it on the high end of that range in the wintertime and the low end of that range in the summertime, you can actually extend the life of your battery. So if you're willing to do that, it will give you a little bit longer life. So we've been talking a lot about dead batteries. The question is why? Well, what is very common in the last decade in particularly is the presence of parasitic loads. A parasitic load, by definition, is a load on the battery when everything is turned off on the battery. There's still a draw there. And oftentimes a battery fails early. Technician just simply replaces it, assumes the battery's bad, and moves on. And then in a very short period of time, that new second battery, which is not cheap, by the way, is dead as well. So every technician or every shop at the very least should have one of these orange items that you see here. It's called a parasitic load test adapter, because to check for a parasitic load, you have to have access to the terminals because it has to be obviously connected to the aircraft. Well, the old traditional style terminals, you can do that, but with an Elcon connected battery, you can't. So what you simply do is disconnect the aircraft from the battery, slide the PLTA onto the Elcon pins and reconnect the battery. And then you see these leads, and that's for your digital multimeter. Turn it up to the highest setting, so in case you've got a large parasitic load, it doesn't damage your battery, but then turn it down very slowly to the most sensitive setting. And if you see the digits start to move or the needles start to crawl, you've got a parasitic load. It's not going to tell you where it is, obviously, and that's what I spent a good portion of my Marine Corps career, was in the tail boom of Cobra helicopters checking cannon plug pins, because parasitic loads were always an issue on those older helicopters. But this at least gives you an idea of where you need to start looking for the issue, rather than just making assumptions about a battery, buying another one, and then it failing quickly as well. So to optimize battery's life, keep it fully charged. Don't overcharge them. Avoid these parasitic loads. Those are some of the keys to making your batteries last. So is an aircraft airworthy with a dead or discharged battery? Only if it was certified with one, and I don't know many, if any, that were. So this is another very important point when it comes to batteries. If an aircraft has a dead battery and started with external power, how long does it take to recharge the battery with the aircraft charging system? Well, the secret's in the watch. It's about 3.5 hours, and here's a scenario where you can get into trouble. Aircraft's on the ramp, it's dead, he's got passengers, the battery's dead. He asks the line folks to give him a jump start. 25 minutes later, he's up in the soup, the generator lets go. If there was not enough energy in that battery to close the relay when it was on the ground, then that battery never got any type of recharge, and there's no essential power in that battery to operate what he needs to get him safely on the ground. So the point is, in aviation, incidents and accidents are never one stroke of the paintbrush to paint us in the corner. It's 6 or 7 things that we've missed, and all of a sudden we've painted ourselves in the corner and we can't get out. So if you don't hear much today, hear this: don't jumpstart aircraft batteries. Discharge minimums. What's the lowest number that you never want to get below? And the answer is C. For 12-volt batteries, it's 9 volts. 24-volt batteries, it's 18 volts. You don't want to get below those numbers. You can get what's called reverse polarity, which is kind of like the diabetes of batteries. So once you go across that hump, it's a little hard to get across it. So you don't want to get below those numbers. Damage: if an aircraft battery has been damaged or dropped, what's the acceptable type of damage? Well, obviously the photos you see here, unairworthy items. But I also want to point out, in these plastic cases, when we were kids, you take a colored piece of plastic and you bend it, you get that white crease. You see that in our containers. That's an unairworthy situation as well, because that battery has taken a really hard lick to get that type of mark on it. If you see this in our batteries, don't sweat it. They're working normally. I do get a phone call fairly frequently about this, but Concorde sealed lead acid batteries carry a positive 1 psi inside of them. And sometimes, depending on where the aircraft is and what the state is, the vent valves burp. So you get that concave or that bulge look to the battery. It can take up to a week for this battery to reset itself to its normal shape. So don't panic. If you want to call me and talk about it, I'd be glad to do it. But no worries. If you see this, it's operating as it should. Concorde maintenance and terminal inspections. It's really important to take a look at these on a fairly regular basis. Clean and lubricate the surfaces roughly every 500 mating cycles, the receptacle contact pins, the engagement socket, the retaining pins, the worm screw. Check the sockets of the mating plug for excessive wear about every 500 cycles. As those sockets wear, that compression force goes away, that springy effect, and you don't get the good mate. So you need to check that from time to time. Also make sure that when you do mate the MS3509 connector, you need to do it horizontally, make sure it's aligned very nicely with the receptacle, because misalignment over time, excessive shear forces, they will gradually wear down the retaining pins inside the engagement socket. So please have a look at this on a fairly regular basis and make sure you're getting good contact and good engagement. The best way to clean a battery, very simply, with a rag and water, no solvents. We're getting towards the end here, so I want to hustle a little bit. One thing you need to understand is that lead acid batteries are 100% recyclable. So from an environmental standpoint, this is obviously a great thing. So make sure that when your batteries are done, obviously not in the garbage, take them down to your recycling center. Local auto parts stores will often take batteries for recycling as well. Installation of eligibility, you can do this a number of different ways. Again, you can go on our website and under the knowledge base and find out what battery goes with your aircraft. But there are different ways to get eligibility for aircraft, either with a mod or an STC. I apologize that AC 2327 is in there because that really just applies to the general aviation piston side of the house. Service bulletins, TCs, 337s, field approvals, number of different ways, but just simply go to the website and that will tell you what Concorde battery goes with your aircraft. Now let me go through some new approvals very quickly and then we'll be done. Piper turbines, we have the upgrade to the RG41 is the RG4153. You see it has roughly 40% more power. This is going to make quicker, cooler engine starts, which is critical when it comes to turbine aircraft. The feedback on this STC has been tremendous. It is just so popular because it is such a difference in power compared to the battery that originally was approved. Also, the G280 from Gulfstream has an approval for 5 batteries, although the 53 really is the one that we are recommending to everyone. You'll need to go through Gulfstream for your first sets of batteries, and then beyond that, you can obtain those batteries through normal distribution channels. This is also another great upgrade. We're getting tremendous feedback from G280 operators who've made this conversion. And then with the Phenoms, the Phenom 100 and the 300, there are STCs available for both of these aircraft. The conversion rate here too has been very strong. It's been a very popular STC for fleet operators as well as single ship operators. We've got a quote there from Gary Veer, who's the Director of Maintenance at Executive Airshare. They've obviously had tremendous results and are very pleased with this. So reach out to us if you'd like some more information or go on to our website. And then this is our team, the domestic sales team on the left, myself. Dave Chavone covers the Northeast. Dave Vega is out west. Claudio Fonseca lives in South Florida. He covers the southernmost part of Florida, along with Central and South America, which is why you also see him over there on the international team. Bob Burkles in Dallas, Texas, does a lot up in Canada, Alaska, and Hawaii. And then Mike Abrams lives in Missouri and covers much of the central part of the United States out west as well. And then on the international side, we have Tony Vella down in Australia. Gary Vickery is in Europe. He lives in Wales. And then again, I mentioned Claudio. Our customer service team is really second to none in our industry. Just a fabulous group of ladies who are so efficient. They will answer the phone. You know, that's one of the big differences at Concorde is when you call us, we actually answer the phone. We love to talk to you, help you out, help you make some decisions and get you going in the right way. So Shelly is in our Atlanta office. Gloria is out west. Those time changes make it so that if you are on the East Coast and it's 6 or 7 o'clock, you can still get a hold of someone in the West Covina office. I don't know if I mentioned it earlier, but we do have a new plant in Atlanta down near Charlie Brown Airport, and then Ashley Parker as well. So just a great team. Very pleased to work with them. We're all here to help you. If you need anything, shoot us an email, pick up the phone and give us a call. We would love to talk to you. So in summary, open circuit voltage does not equal state of health, does it? It's 2 entirely different things. If you want to know the state of health of a battery, cap check it. Cap checks don't shorten the life of a battery. So if you're uncertain about a battery that comes in your shop, charge it up, check the open circuit voltage, charge it up, and do a capacity test. Capacity tests are the only way to determine airworthiness. Don't jumpstart batteries. Take the time to charge them up or get a new battery for that aircraft. and then simply keep them fully charged. And obviously don't overcharge them. And always refer to the component maintenance manual for instructions. So with that, I am all done. I appreciate your time, and we will turn it back over to me.